Hey, thought I'd do a little video on just some different things you may not know. You may have heard some certain terms in metalworking and not know what they mean exactly. So I'm just going to go over some real basic ones that just pop in my head as I look around my shop. So if you're a professional metalworker or professional blacksmith, this video is not really for you. You probably already know most of these terms. This is for the beginner guy wanting to learn some of the basic things, just doesn't know. He's heard the words before, doesn't know what it means. Okay, so there's some real basic ones when it comes to metal, like steel specifically, but most, would cover most metals, like let's just say hardness. Okay, hardness sounds simple enough, and it kind of is, but there's a lot of different scales in hardness. There's Rockwell, and there's I don't know, there's a couple others, but Rockwell is the common one in North America. It's probably different in Europe. And basically, it's just a test of how hard or how solid metal is, because you can be squashed or what have you. The harder it is, the less likely it is to be compressed. Compression is also a term in metalworking. I won't get into how they test hardness, but it's done in a lot of different ways. But we'll move on. In metal, there's also a very common one called tensile strength, which is basically pulling the metal apart. Like if you were to take a steel bar and then hang tons and tons of weight on it, how long it would take before it actually ripped apart. And that would be the tensile strength. So steel's usually around 36,000 or something, just for mild steel. And it can go way up. It can go up to almost 300,000 pounds per square inch for some very exotic steels. Another common one is yield points in steel. There's the low point and the high point, but yield generally means if you were to take a bar, you know how you can bend a steel bar, and if you let it go, it goes back to what it was. At some point when you're bending a steel bar, it stays bent. That moment where the crystals stretched and stayed that way is the yield point. In blacksmithing, there's quenching, for example. You kind of know what that is. It's just the dunking of the metal into water or oil. Sometimes quenching is just leaving it out in the air. That's even quenching, is if it's cool air compared to how the material cools down and its relationship to the ratio of how fast it cools down. That's quenching. The opposite of quenching would be annealing, which means to take a hot metal and bury it in sand or somehow insulate it with a fire blanket, or it could be anything. There's a lot of different materials to use. You can use perlite or whatever. And it just slows the cooling process down, making the material very soft. It makes it ductile. So ductility in metal means its ability to malform to different shapes over and over, or easily, and not work hard and as fast as material that is normalized. Normalized metal is metal that came out of a factory. It goes through the process of its manufacturing, and basically its normal state means material that was normalized. If you somewhat mimic those properties, like say you heated a steel bar, you took it out and you more or less just threw it on a countertop or a tabletop and just let it cool on its own. With mild steel, that's generally normalizing. The manufacturing process wasn't much different than that, so it usually comes out about the same. Alloy is different metal components put together. So if you were to put, if you had just titanium alone, it's not a very good metal. If you add certain components to it, aluminum, there's many other things you can add to titanium. I don't know. I'm not a titanium master, but I know aluminum is one of them. Stainless steel is usually just steel or iron with lots of chromium or some other things. You can add a lot of different things to stainless steel. You can have an alloy with literally dozens of other metals contained within it. Steel generally has like 5 or 6 actually. There's trace elements of certain little things in steel that make it better to work with. It's not just iron and carbon. There are other things in there. There's manganese and some other stuff. Work hardening is, if you've ever taken a wire and bent it back and forth until it broke, you were doing the process of work hardening. Basically, it's moving the crystalline structure of that material to the point where it just doesn't want to move anymore. It's good. It can stretch so far each time, and then little by little it becomes brittle, and then the boundaries between those crystals give up, and that's basically work hardening to the point of destruction. Then there's case hardening. Basically, that is, you've all seen it on cheap knives or whatever. Basically, it's just taken like a very relatively soft material and putting a very hard skin on it by adding a lot of carbon. Usually this is the case with steel. You can case harden anything for the most part, but it's generally a term used with steel, taking sort of a medium carbon steel and putting a high carbon steel thin skin on it by heating the outside of it to almost a liquid point. You get like just like a wet look about steel on the surface, and then adding carbon to that and quenching it, and so you end up with case hardening. Hard facing, you may have heard that term. It means basically taking some very hard elements that are contained within a hard facing welding rod or welding wire and putting it on the surface of something, like when you see on excavator buckets, you see a little X pattern on the bucket. That's all hard facing, and what it is it's very resistant to abrasion, so that the plate lasts a long time. You don't have to buy a new bucket or rebuild the bucket very often. That extra material doesn't wear away very fast at all. You can also use steel in buckets or blades. Up here it's called AR plate, which means abrasion resistant, and that's where you would usually use it in products in excavation or what have you. Okay, here's a simple one. Welding. Welding means the fusion of two metals, either similar metals, or here's another term, dissimilar metals, which can mean you could weld steel to stainless steel. That would be dissimilar metals. Welding is actually physically melting it to a liquid molten state on both sides, putting them together and allowing them to freeze. That's a weld. Something like brazing, which is like using a brass brazing rod or a bronze rod dipped in flux to what appears to be welding, dissimilar metals or similar metals. It's sort of an old technique. It still gets used quite a bit to fix iron and things like that. That's actually not welding. It's called cohesion, which means you're creating a bond at the molecular level. And don't confuse cohesion with adhesion. Adhesion is a completely different thing altogether. Tempering is something you do after you harden a material. Actually, tempering can be done on materials that aren't hardened, but usually it's done on material that's hardened. And what it is basically reheating the material after it's been hardened from a high temperature. You can reheat it either from cold or from a low temperature to a high temperature, but not high enough to change the crystalline structure. And what it does is it removes the brittleness. Tempering is a term, it's thrown around, but it is completely different for every material. People will say, well, did you temper it? Well, you can loosely throw that term out there, but tempering every alloy is completely different. The processes are completely different. Sometimes there's more than one heating step. Sometimes tempering has to happen in 2 or 3 stages. And like I say, it's a very complicated process, and it's very specific to the material. Many people like to pretend that they know how to temper something just because they know what that material is right off the bat. Take it with a grain of salt, because a lot of people really, they don't know what the hell they're doing. Just some basics around the shop, like MIG, TIG, stuff like that. Let's just explain what that is. MIG, the term MIG, you probably know what a MIG welder is. Why is it called MIG? MIG is an acronym for metal inert gas. It just means there's metal, there's an inert gas, you've got some welding happening. It's a term that's kind of crazy. It doesn't really make sense, but TIG welding means tungsten inert gas, and basically just means you have a tungsten electrode instead of a metal electrode like in MIG that melts. Tungsten doesn't melt, or at least it shouldn't melt while you're welding. Sometimes it does. So tungsten inert gas, metal inert gas. Then sometimes it's actually used in a little bit more scientific terms. It would be GTAW, which means, hold on, I gotta make sure I'm getting it right. Let's do the MIG one first. GMAW, gas metal arc welding. GTAW, gas tungsten arc welding. Right, I'm trying to remember as I go. Shielded metal arc welding is SMAW, which means stick welding, as you've probably seen. You may have seen that one. You may have noticed in my last video it was titled forming finials, not forging. Forming means to bend something into a shape. That's forming. Putting a piece of steel in a break and just putting a bend in it, that's forming metal. Stamping a piece of tin metal into a shape. Using an English wheel, that's forming. You're not forging. Forging means to compress the metal to a point where it completely reshapes it. I know it's kind of vague there, but forging can be done hot and it can be cold, contrary to popular belief. There's cold forging. If you put a steel bar on the anvil and you smash it and it's cold and you can smash it flat, I mean it's going to hurt your hand. You're still forging. You're not just not hot forging, you're cold forging. And again, it's sort of a vague boundary there, but for the most part, forming is bending sheet metal. So if you're doing repoussé work, which is the forming of sheet metal into exotic tin shapes, like if you've ever seen a tin ceiling or something like that, it's something like that, even though those are stamped. But if you did that by hand, that's repoussé. Clinker is slag that builds up in the bottom of a coal forge. I think even in a charcoal forge, but it takes a lot longer because mostly you just get ash. But what clinker is made up of all sorts of things. It's sort of the mineral components that kind of leached into the coal over the millions of years. There's lots of other minerals in with coal. It's a rock out of the ground. It's got all kinds of things. There's sulfur and all sorts of crap in with them. Little bits of rock and sand, all kinds of things. And sometimes it's the metal scale off your work. It all gets blended together and plugs the hole at the bottom of your forge, and you have to clean it out once in a while. The reason it's called clinker is if you take your clean out tool or a little steel bar or something and you tap the coal, coal is it sounds like you're hitting popcorn. It doesn't really make any sort of hard noise, and then when you find a clinker, it'll kind of clink a little bit. That's why it's called clinker. Tool steel is nothing but any hardenable metal that you use to make a tool. Cutting tool, machine tools, usually stuff like that. Something that's meant to cut other steels. So usually that's tool steel. Oxides or oxidation is basically it's a rust. You know, it's rust. It's rust in iron. So that is an oxide of this. Some metals are prone to reacting with oxygen at room temperature, such as this iron, this steel table. You know, got a little water on it, oxidized. The water was sort of a catalyst for the oxidation, but it'll rust on its own eventually. Some materials oxidize very well at higher temperatures. In fact, most of them do. Some metals oxidize perfectly well, very fast at room temperatures, such as aluminum. A lot of people don't even know this about aluminum until you get into TIG welding and stuff. You don't even have to deal with it. But believe it or not, all aluminum has a very hard oxide on it all the time. Right from the get-go, as soon as you grind aluminum, as soon as you cut it or what have you, you're getting below the oxide. It's very thin. It's only a few atoms thick if it's fresh. But the crazy thing about aluminum, oxidizes at room temperature instantly. So even within like 10, 20 minutes, there's a pretty good oxide layer on the surface of aluminum. And this is why you have to have AC current, alternating current, to TIG weld aluminum. And the high frequency helps to rip the aluminum oxide atoms away from the material so that you can weld it. Way back, I guess, in the old days, long before my time, but way back before they understood aluminum very well, they would have somebody grind it, like in between the time when they were doing gas welding, because it was just so expensive to do gas welding on aluminum. It was very expensive. And before they really understood TIG welding, what they did was they tried to TIG weld it with DC. They'd have somebody grind it, and as quick as that person could grind it, they would use helium and a DC weld to DC arc to TIG weld the aluminum together. And I've tried it, it works, but you got to be very fast because it oxidizes so quick. Now, on the other hand, some materials are very resistant to oxidation, such as titanium alloys, and this is why they're put into spaceship parts and very high velocity aircraft parts, like the SR-71. That was all made of titanium because it would get so hot the skin would actually glow. If it was made out of anything else, it would just oxidize because there was so much oxygen and so much heat going past it. Really nothing else could put up with it. Stainless steel is very good at not oxidizing. Good stainless, like 316, is very good at not oxidizing. But get into the different alloys and stuff some other time. But anyway, I think that's probably, I've covered a lot. It's probably going to be a fairly long video, so I'm just looking around trying to think of some more stuff. But there's a plasma cutter here. What is plasma? Well, all plasma is in the tip of the gun. There's an arc, and it gets swirled around at supersonic, even I believe hypersonic speeds, and it heats up the atoms so much that it literally becomes a plasma. It goes from it turns the gas from a gas into a plasma, which is a completely different state of matter, and that's what that is. Looking around, trying to think of more. I don't know, I'm running out of stuff. So anyway, we'll talk to you guys again soon. Cheers.